Our objective for this lab experiment 6 is parallel connector resistances. If the two resistances or impedances in parallel are equal and of the same value, then the total or equivalent resistance, RT, is equal to half the value of one resistor. We know now that resistors that are connected between the same 2 points are said to be in parallel.
The material that we're going to use is the FET simulator circuit construction kit DC.
Good morning everyone, my name is Joules Orbina and I'm assigned on the procedures. We need to find the needed values with our voltmeters. We need to make a parallel connected circuit with 3 ammeter and 3 capacitors in parallels. We then set our voltage in 20 volts and we then change the values of our capacitor in different trials so that we can gather our data.
Hello guys, my name is Suplido, the one that is assigned in our data, diagram, and computations. As you can see here in our table, we assigned a constant value for our total voltage, which is 20 volts. We also assigned values for R1 and R2, which are of the following: 30 and 35, 40 and 45, and 50 and 55. With the formula 1 over RT equals to 1 over R1 plus 1 over R2, we'll get the total resistance. Afterwards, we put the assigned values to the FET simulator and get the resulting currents and voltages. We repeated the same process all throughout the trials. That is all for our data, diagram, and computations. Now let's move on to our analysis.
I'm Joules Sargado. I'm here to talk about the analysis of lab activity number 6. Parallel circuits are used for creating more complex networks like multi-way switches. Upon using a voltmeter, we can figure out the value of the individual voltage of the resistor, and by looking at the ammeter, we could have the current's value. The voltage across resistors in parallel will be the same for each resistor. If 2 or more resistors are connected in a parallel, then the potential difference across all the resistors is the same. Resistors in parallel connection are connected to the same nodes from both ends. Proving this is when we input all the necessary data in the circuit and individually identifying the voltages with the voltmeter. Shown in the table, the value of the resistance 1 is bigger compared to the total resistance, and also for the second resistance, where it's like the average of them. Moving on to the current will be in proportion to the resistance of each individual resistor. These can be identified by the presence of more than one way for the current to flow. The potential difference across the resistors is the same as that across the resistor, which is equal to the supply potential. To demonstrate it, we would use the trial 1 as an example. To find the current 1, we should divide voltage by the value of the resistor, R1. We could have the mathematical sentence: current 1 is equal to voltage over resistance 1, which is equal to 20 volts over 30 ohms, which will give us the value of 0.67 amps. Also, we would like to add up that in order to get the total current, we need to add up the individual currents, current 1 and 2. This means that the value of total current is dependent to the value of the individual current. For more analysis, Here we have Aries.
And thank you for that, Joules. And as we had observed, parallel circuits are arranged such that the current can travel through different branches simultaneously. Voltage, not current, is constant throughout, and Ohm's law can be used to calculate voltage and current. In series parallel circuits, the circuit can be treated as both a series and a parallel circuit. Thank you everyone for listening, and we can move on now to our conclusion.
Hi, I'm Geffroi Recabar and I'm assigned for the conclusion for the laboratory experiment number 6. When resistors are connected in parallel, more current flows from the source than would flow for them individually. So, the resistance is lower. Each resistor in parallel has the same full voltage of the source applied to it, but divide the total current amongst them. Therefore, I conclude that we have confirmed the principles that govern parallel connected resistances. Thank you.